Okay, so our second topic for today is Kotlin Coroutines basics for Java developers. And we're going to talk about what coroutines are, how to use them, and we'll also talk about special Kotlin keyword and coroutine related naming and stuff. Yeah, so my name is Grzegorz Witczak, which might be tough to pronounce, so you can just call me Greg. I've been working on Java backend for the last seven years, half of them here at Dynatrace. Now I work as a Kotlin developer, and besides of that, I also teach people how to code. Okay, so for those of you who have never heard about coroutines, this is a kind of Kotlin way of doing concurrency in code. So if I would have to use just two words to describe coroutines, it would be lightweight threads. Let's have a look at this short animation. I took it from official Kotlin site. And as you can see here, we have tasks, the letters that are being executed, that are being moved by the threads. Does it look similar to anything you've seen already in Java? I would say that it looks quite familiar to me because, you know, we don't need to like focus only on a pure old thread class. We have fewer newer stuff in there, like executor service, the thread pools, the parallel streams, and whatever. And yeah, we can do pretty much similar stuff to what we've seen here with it. So why do we need any coroutines? It looks like same old shit, different day. So, and this might be a bit disappointing to some of you, but kind of like under the hood in Kotlin Coroutines, we still have threads and stuff. It's not some super fancy new technology that would change the world. Yeah, sorry for that. And are coroutines a revolution? Yeah, like not really. I would say that it's an evolution because with coroutines, we have a new, more clear and easier way to use concurrency in our apps. And this is a part of syntactic evolution in programming languages. Just like Java evolved from C, C++. You remember if you've ever coded in C, you had to worry about all the pointers and stuff and missing some stuff in memory and invalid references. Yeah, kind of like Java fixed most of those issues. And here it's kind of like similar. We take a step forward and do it in a different way that's, I guess, better. Yeah, but okay, you know a little bit of background, and that will do for now. As Linus Torvalds once wrote, "Talk is cheap, show me the code." So let's learn coroutines by studying the code. And before we actually start with the code, just some kind of like information that most of the examples that I'll be showing here will also have a Java code, exactly like Piotr showed it to you. And it's here because I want to help you understand the stuff and kind of like by looking at something that is more similar to you if you're not using Kotlin on a daily basis. However, just please have in mind that this doesn't mean like the same bytecode would be produced because the examples that I'll show you are equivalent in terms of how they work and not like in terms of what would be the bytecode underneath. Yeah, so let's have a look at super simple Java hello world that uses sleep, kind of like two prints and the thread sleep in the middle. Yeah, I guess that's pretty basic. And if we run this code, the result would also be something that we totally expected to be. So now let's have a look at Kotlin way of doing stuff here. So we have two print statements, and between them, instead of just putting sleep, we are creating a new coroutine and waiting for its execution. We're using a coroutine builder called run blocking, which runs the code under the parentheses and kind of like blocks the main thread here until it finishes. And then in coroutine code scope, we have just a simple delay. It doesn't look like complicated, but it's also synchronous. So let's run something in a real asynchronous way. Yeah, and now, yeah, here we have the Kotlin example, and here instead of run blocking, we'll be using launch here, which basically means that we are running something, and in this run and forget style. So we'll run it, and then we'll proceed further with what's in our main function. So kind of like fire and forget. And what do you think would be a result of running this code? Yeah, that's the problem, because we won't see the actual word statement, although it's here. And that's because the main method and the main thread has finished execution after just few milliseconds from start, and it just shut down everything. Why does it happen? Yeah, maybe let's look at equivalent Java code. So here we create new thread, and we're explicitly setting the daemon flag to true for this thread. For those of you who are less familiar with concurrency word, a daemon thread runs in a background and does not block application from shutting down. So like in other words, our application is running as long as it has any non-daemon threads. So in this case, of course, we would get the same results. Only hello, no word. So now if we want to do it correctly in Java, we would of course just kick out the setting the daemon to true. But also the other way would be just to hold on with main thread for a few seconds longer by introducing some extra sleep here. Yeah, so if we convert this code to Kotlin, then of course we can do it. Here we would create a new coroutine in this launch coroutine builder. It would sleep for 1 second and then print word. Then, but in a kind of like in a main thread, would print hello, and then just wait for 2 seconds to let the first coroutine finish. So this would of course produce the code that we expect and the one that we're interested in. Of course, it's not like a super good way to sleep at the end of main threads to have everything going, but let's consider this as just a simple example here. And maybe let's do something a bit more complicated, but only a little bit. So let's assume that we would like to return some value from our thread. In Java, we can't do it in like super easy matter. We need to use something a bit more advanced than thread. So I've created a single thread executor here and submitted a task here. So task is basically to sleep for 1 second and then return the word string. So as you can see, after calling a submit method, we do get in a response the future object. And like future is a handler, and we can use it later to just retrieve the value using the get call. So that's pretty nice. We need to write a lot of code, but it does work. And the result would be, of course, something that we'd expect. What about Kotlin? I would say that it looks much cleaner and easier this way, because kind of like having this future-like object, it's already built in coroutines, and it's not like something that we need to use externally outside and such messy as usual with Java. So the async coroutine builder that we are calling here, it will just launch an async task and return us the future-like object. I call it future-like, but its actual name is deferred, and the Kotlin team picked this name because it wasn't used anywhere else. So, but it basically works in the same way. We can use it later to just retrieve the value that we're interested in. And of course, the result would be exactly what we expect. Okay, and remember, like 10 minutes ago, I said that coroutines are lightweight threads. Yeah, let's try to run such code. We'll create, let's just create 100,000 coroutines and see what happens. Each one of them should just wait for 5 seconds and print a dot. If we run it on Kotlin, then it's working perfectly fine. It took on my machine 5.5 seconds, but it printed all the dots. I've counted. And that's pretty cool. Now let's try to do something similar in Java. As you can suspect, it's not a good idea. Basically, it's horrible idea, because spawning each new thread, if I recall correctly, each thread takes at least 4 kilobytes. So we will very soon end up with out of memory error and kind of like our whole application crashed. Of course, like nobody would do this in production code especially, but still, this is what we mean by lightweight threads. There's like no extra charge, no extra cost for creating them. And we totally agree with Vader that it's impressive. So to kind of like have this short summary, the coroutines can be used as cool Kotlin alternative to standard Java concurrency. But that's not the only benefit we have. And in order to find out what's more, we need to go deeper. And we need to understand better how the coroutines work and how to use them in a correct way. Yeah, so now let's go to a bit more complicated part of the talk, and let's talk about the coroutines concepts. And we'll start with new language keyword called suspend. So this is kind of like the language keyword. So kind of like similar like in static in Java, but of course it works completely different way than static. And suspending functions are like special functions that declare that they will take some time. It looks like a bit of mystery at the start, but if we think just a little bit about it, it makes sense. So the suspending functions may suspend the execution on the current coroutine without blocking the current thread. And it's especially cool, for example, if we have some heavy I/O operations or some networking stuff going on, then kind of like not stopping the current thread and waiting for the result, but just switching automatically to something else. This gives us benefit. Yeah, and that's pretty cool. From inside of suspending function, we can reason sequentially about function calls. So it's like if you write a suspend function, then it feels like a regular old sequential code. We don't need to worry about some callbacks. We don't need to worry about the future tasks and do whatever with that. We just write the code and it will be run kind of like concurrent. So that's pretty cool. So how to use suspend functions, and it's a bit of surprise. We've already did it. Remember the delay function that we used instead of thread sleep? This is a suspend function, and it kind of like makes sense. It will take some significant amount of time to just sleep. So it is a suspend function. And also the other one in deferred, the future-like object, we've used the await in order to get the future result. And this is also a suspend function. So it's not like tough to use the suspend function. And it's even easier to read the code with suspending functions if you're using right IDE. So here in IntelliJ, you will get the suspend function call icon on next to a function call, and it kind of like helps you to read the code and see what's going on. Okay, cool. So we've already used suspend functions, but how to write one? Whoops, we've already did it. The piece of code, for example, the one that we wrote here on the last example, it is a suspend function, and we can refactor it to just have it as a separate actual function, like separately written in code. And this would also be a suspend function. So it's not like difficult to write a suspend functions or to use them. it kind of like feels more natural. So it's cool. Okay, and what we've also used already are coroutine builders. I've mentioned it previously, but now just let's talk about it a bit more explicitly. Those are simple functions that create a new coroutine to run given suspending function. So, and we've already seen a few of them. For example, the run blocking, the first one, and it actually blocks the current thread and waits for the execution to finish. It's not like feeling very asynchronous because it's not, but it's cool if you want to kind of like check something pretty fast, just see whether it works or not, and especially if you're writing tests, then run blocking is very useful. The launch fire and forget background coroutine, we've already seen that. You just launch it and you don't care whether it like finishes or not, or when and where is the result. And if you do care about the returned value, if you do care about the result, just use async and get this deferred object to to read the result. Yeah, so coroutine builders can be called from normal non-suspending functions like main because they are not suspending themselves. So they can like act as a bridge between regular word, the normal word, and the suspending concurrent one. So it's nice to use them, or in other words, it might be tough to use coroutines without them. And those are kind of like the entry points if we care about them. Okay, so now let's talk about coroutine scope. So coroutine builders that we've seen already, they automatically create a new coroutine scope. And this is within the scope, as you could suspect. So for example, here, the run blocking is a coroutine builder. And if we write code inside of this, we are using the coroutine scope of this coroutine as this. So if we write launch to start another child coroutine, if we use launch or this.launch, it doesn't matter because it's exactly the same code. So I guess it makes it pretty easy to use. Okay, and yeah, so what you need to actually remember is that coroutine builders automatically create a new coroutine scope. Whether you want it or not, it will be there. And the scope is responsible for child coroutines. So it means that it can automatically cancel child coroutines. If you, for example, cancel the main one or some core one, then all of its children will also be canceled. And you automatically wait for completion of all child coroutines. So it kind of like makes it easier to track what's going on and to make sure that there's no like some loose thread that is executing still something and we forgot about this. Yeah, because kind of like if you write in classic Java, then it can be quite tough to just keep track of everything. And here in Kotlin with coroutines, we have this new approach that's called structured concurrency. And it takes some time to get familiar with it and to kind of like get used to thinking about it in a different way. But I would say that it's worth it. Yeah, and one last new concept that we have for today is the coroutine context. So coroutines are always executed in some context. And part of this context would be, for example, name. Just it's optional, like with threads, you can pass the name or you can just have a default. You will also, as part of the context, get a job object. A job is a handle on coroutine that allows us to modify its lifecycle, for example, to cancel it. And if you're thinking about this deferred future-like object, then it's exactly the thing, because deferred actually extends the job. So job is kind of like the be more kind of like the universal, the one that you can use always, the base type. And we can also, usually we do have a dispatcher. The dispatcher determines which thread or threads the given coroutine will use for its execution. And it's kind of like, it's a bit outside of scope for today's presentation, but think about, for example, the Android apps, that you do have an UI thread that's it's kind of like active and for drawing the stuff on front end, and you do want to like explicitly do something in a background thread to just don't clutter the UI thread. So it makes it really easier, and that's the way to go. Yeah, and let's see the coroutine context usages on this simple example. So here in launch, as a parameter, we can pass the coroutine name. So this would be pretty cool. And the launch, as I've mentioned, it's fire and forget. But if you don't want to forget about this, you can, of course, grab the return value, and it would be a job object. And then you can, of course, cancel the job or join it or whatever you want. The code that you will see here, it will, of course, correctly cancel the coroutine, because it won't run for long enough to print the log. Okay, so here we have basically the same example, and let's practice a little bit and see what is what here, and kind of like sum up and see who's who on this code example. So here we do have a coroutine builders. It's run blocking and launch. Here we have the coroutine scope, which is within the braces. Here we do have a coroutine handler, the job object that we can use to cancel it, join it, or whatever. And we do have suspending functions calls here, the delay here and there. So a lot of new naming, but you can get used to it, and it's not so bad. And what about the coroutine context? Because I haven't seen it, I haven't put it on a previous slide, because basically it's a part of coroutine scope. The coroutine scope consists of coroutine context, which is immutable. And if you use the coroutine builder, like the launch or run blocking or whatever, it uses two coroutine contexts, the parent and the child. And that's how we can like know who's the father and who's the child here, and we are able internally to kind of like track everything. But this is just a little bit outside of the scope for today. So now we have a super small live demo. So let me just switch for a second. I'll share my screen. Okay. Okay, is it working? Okay, perfect. Whoa. Okay, this is also working. So I've prepared a pretty small code example. Let's just start from a bottom. Here we have super naive function that would check whether the number in the parameter is it prime or not. So this is a little bit CPU intensive task, especially if number is big, because this algorithm is horrible in terms of performance, but it's totally deliberate, and we want it to be this way. And here we have a method that is checking the number info, and the number info will be the number, kind of like the basic data class that holds the number, whether this number is prime and whether is it not prime. It's of course also a bit dumb to check it, but this is because we have a simple method, check number info, here in synchronous way, that calls the is prime and is not prime methods to functions to actually do some CPU intensive tasks and calculate whatever we'll get here. So, and if we have this method, we can, of course, run it on a pretty big random numbers, and it will take some time. And here, in this case, we do have it in a completely parallel way. So it took like 3 seconds to calculate 100 pretty big random numbers and to check whether they are prime or not, kind of like twice for every one of them. So let's have a look at what's going on in the code. We have the round blocking here because we want to see the result in a main thread. Here we have kind of like the loop that would run 100 times. So we will repeat this code 100 times. We kind of like just throw a dice and get some random number. And then using a default dispatcher, we are launching the check number info method that does some calculations and returns us the result that we print here. So now let's have a look at the method. So what's going on? We're spawning kind of like child coroutines here using the async coroutine builder. So here would be the one child coroutine for calculating whether the number is prime, and here the other one to calculate is it not prime. So kind of like to do the same job twice, but that's cool for now. And here, of course, we just wait for the actual execution to happen to just return the value. And this code, if we run it in 3 seconds, it's kind of like the best that we get from this algorithm. And what would happen if we just replace the check number info method with the simple method that would not use the child coroutine context and would not use the async coroutine builder. So we would just spawn 100 coroutines, and each one of them here would be the 100 launched, and each one of them would just call the method that is doing everything in a simple sequential way. As you can imagine, we would get worse time. Let's have a look at it. Yeah, we had 3 seconds previously, and now it took like almost 5 seconds. So it's worse. And what would happen if we would run this code in a totally sequential way? Yeah, so let's just comment out spawning a new coroutine, and then we'll just have one coroutine that is blocking. So just like we wouldn't have any, that just has a 100 iterations loop and checks the other random numbers, whether they are prime and not. And of course, the performance here would be worst one. I believe it took like 11 or 12 seconds, but let's see. Yeah, 12 seconds. So kind of like it shows you how simple it might be to just add the concurrency to the existing app. So you just need to spawn a coroutine, use the coroutine builder, and then kind of like no super much of the extra code is needed to have it concurrent. If it would be kind of like classic sequential Java application, you would need to pretty much write everything once again to use the thread pools, the executor service, etc., etc. Here in Kotlin, I would say that it's easier. Okay, so let's go back to slides. I'm stopping my screen sharing and going back to the slides. Okay, so hopefully it's working. So just let's sum everything up and see few key takeaways. So coroutines are lightweight threads. That's something that I would like you to remember. If you need to just remember one sentence from this whole half-hour presentations, it should be this one. And coroutines are using so-called structured concurrency, the one that has some child coroutines and parent coroutines and stuff. The suspend functions are functions that can run in coroutines, and we can create coroutines and handle them with scope, context, and job. So those are kind of like the important words. And the last one, pretty important, coroutines are cool, or at least that's my personal opinion. Hopefully you also share it. And we've covered only basics of coroutines. There is much more to discover, and just a few things that we skipped for today. Those would be the dispatchers, the exception handling, sharing data between coroutines. It's also possible. And why using the global scope that we used is a bad idea. And the internal implementation of coroutines. And let me just spoil you a little bit the last one. It's using callbacks internally, and that's quite interesting. But if you're feeling that this is very complicated, then don't worry about this. This was a short half-hour presentation with a lot of new knowledge, and it's totally fine to be a little or even much very confused about this, because in order to start using coroutines, you need to learn a little bit more and have some practice. So I'd recommend you learning from the great conference talks by Roman Elizarov, the Kotlin project lead. Those are like about 1 hour's YouTube movies. Also, the official Kotlin documentation is a good way to start, especially they have this hands-on tutorial based on the workshop, and it's pretty nice. You just use the retrofit library to make a lot of network calls to GitHub and to fetch data. And it's really nice practice. Of course, we have also a vast number of tutorials and videos available online, so it's also cool to just check them out. Yeah, and this would be all from me. Thank you for your attention.